Hey everyone, welcome back to the Workplace and Apprenticeship 20 videos. In this video, we're going to look at lesson 2 from chapter 6, which is talking about compound interest. So in the last video, we looked at calculating simple interest on either investments or on loans, but not all loans or investments involve simple interest. In fact, most of them don't. So if you keep the interest earned in your account, new interest could be paid on the principal plus that interest that you kept. So this here is what we call compound interest. So compound interest can be paid more than once a year, and the interest rate is stated per annum, and it can be divided by the number of compounding periods per year. So say, for example, if the interest rate is compounded semi-annually, which means our number of compounding periods a year is twice, or 2, so what we do is we divide the interest rate by 2. If you're paid quarterly, which means 4 times a year, we divide our interest rate by 4. If it was monthly, our compounding periods would be 12 in a year. So we divide our interest rate by 12, and daily would be 365. And so we divide our interest by 365. So essentially what we do is we divide our interest rate by the number of compounding periods. So here we're talking about the types of interest rates and how it's being compounded. This here tells us the number of compounding periods in a year. This here will be particularly important for the next example. So it's going to be important to understand what semi-annually means, what quarterly means, what monthly means, and what daily means. So we could calculate the compound interest using our simple interest formula, but that is an immensely large amount of work, and we have this compound interest formula that can help us out big time. So here we have the formula for compound interest. So here it states that A is equal to P times 1 plus R over N, all to the exponent of N times T. So in this case here, your A value here is your total, which is your principal plus the interest. P is your principal. And I actually don't have that written here, so I'm going to write that below. So P is your principal. And then R is your interest rate. Remember, this one here is as a decimal. N is your number of compounding periods. So that's that list that I had just above. And T is your term. So one thing to really note here, it's a little bit hard to see this on Word, but N and T there are exponents. So your total, which is your principal plus your interest, is equal to your principal times 1 plus your interest rate divided by the number of compounding periods, all to the exponent of the number of compounding periods times the term. Now in terms of this equation or this formula, there's really no easy way of trying to help you remember this formula, so you're really just going to have to memorize it. And so part of trying to memorize an equation is practicing it. So we're going to do example 2b from our notes. So here we're going to calculate the final value of an initial investment of $6,000. Interest is paid at 4% per annum, compounded semi-annually for 3 years. So in order to solve this question here, I'm first going to identify, well, what were they asking us to do? So here we need to calculate the final value of an initial investment. So here we're looking for the final value, which is that A value. So that's your total at the end of your term. So here we're told that the initial investment was $6,000, which that there is your principal. So your principal is $6,000. So your interest rate paid is 4% per annum, which is 4% per year. So your R value is equal to 4%. But remember, we want this as a decimal. So we're going to divide this number here by 100. Which would then give us 0.04. Then we're told that our interest is compounded semi-annually. And if you remember that is in our list above. So semi-annually means twice a year. So our number of compounding periods is 2. And then we're told that this is over 3 years, so that is your term. So now we're going to fill in this information into our formula. So I'm actually going to start even just by writing that formula first. So we have A is equal to P times 1 plus R over N to the exponent of N times T. So here we're looking for that A value. So I'm going to leave my A value in that formula. I'm going to put 6,000 in for P, times it by 1 plus, so be your interest rate, so 0.04 over the number of compounding periods, so over 2. And then that's all to the exponent of N times T, so 2 times 3. Then what I'm going to do is I'm going to simplify this equation just a little, or this right-hand side here just a little bit before I can really plug anything into my calculator. So I'm first going to simplify this division here, or this fraction. So 0.04 divided by 2 is 0.02. And I'm also going to simplify this multiplication in our exponent. So 2 times 3 is 6. Then I can simplify inside my brackets here. So I want to go 1 plus 0.02. And that will give me 1.02. So when I get to this point, this here is when I can put all the information into my calculator. And I'm just going to give you a word of caution here. Make sure you watch where you put your exponent. You might need to put brackets around 1.02 and the exponent of 6. That way your calculator doesn't try to multiply these two numbers first, then do the exponent. So you might need to put brackets here, just to make sure you do not get a calculation error. When you put that into your calculator, we should find that the final value of that investment is $6,756.97. So this one here wasn't a word problem, so you don't need to answer this with a sentence, but make sure you put your units here, which is that $sign. So that there was an example of using your compound interest formula. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.